Hello, everyone, and welcome to today's Tech Excellence session. As you already may know, our vision is to raise the bar of technical excellence across the world. So, who are we? Valentina, she is founder and organizer at Tech Excellence. Daniel, Oliver, and myself, we are co-organizers and co-hosts. So this year we prepared a lot of great speakers for you. Stay with us. You can find out about our sessions and follow us on different social media platforms such as Meetup, YouTube, LinkedIn, Twitter, GitHub, and Discord. Our sponsor is Optimum and our partner is QE Unit. So today we are really happy to introduce Niels Malotaux. Niels is an independent project coach and expert in optimizing team performance. The title of his session today is Help, We Have a QA Problem. But before I hand over to Niels, I want to remind you that you can leave your comments anytime in the chat below. In the end of our session, we will have a 30-minute time slot to discuss them. So Niels, enjoy your presentation and good luck, and we see us in approximately 1 hour.
Thank you. Thank you. There we are. So welcome, and let's talk about QA problems and how we solved it. So who am I? As already said, I'm coaching teams to deliver better results in less time. More effective, more efficient, more predictable. And if you think that's not possible, let's try it, then you can see it is. Because usually I'm asked only if projects are in trouble or teams are in trouble. We sometimes also call it project rescue. And from time to time, I even eat my own dog food by developing some electronic product, because actually by birth, I'm an electronics engineer. The project types that I've been coaching in the past, let's say 23 years, is, well, anything. Because the technology is not the issue, it's usually the human behavior that is. So electronic products, firmware, software, space, road, rail, telecom, anything. And the idea is to let them deliver better results in less time. And I call that quality on time, the right result at the right time. So there was a company in some country where I had been asked from time to time to help them in delivering better results in less time. I went there a few days a year, and then the R&D boss could use the same furthermore. But then at one February day, he called me. He said, "Niels, we have a QA problem." I said, "A QA problem? Do you mean testing problem?" "Yeah, yes, we have a testing problem." Most people think QA and testing is the same, and of course we know that's not true. But he had a testing problem. Okay. And I said, "What's the problem?" "Well, we have this large stockpile of modules to test. And we have to do, according to the boss, we have to do full regression tests on everything we change. And full regression tests take about 15 days each." I said, "Oh, interesting. Yeah, no automation apparently. And we have too few testers. Yeah, there were 2 senior testers, and one of the testers went to the boss and he said, 'Boss, next door I can get much more salary. I want more salary.' And then the boss said, 'I don't give you more salary,' so he left. Result, only 1 senior tester left there. So the R&D boss calling me said, 'Should we hire more testers?' I said, 'Wait a moment. Let's first see what the problem is before we go into solutions that solve the wrong problem.' So the senior tester, actually, when I went there, I saw the picture like this, paralyzed. He was sitting there. Yeah. And he said, 'Can you help us?' can you help us? I said, I think I can. Then he asked, how do you know? Good question. Well, I said, I've handled questions like this quite regularly, and usually within a day we can solve the problem. So maybe in this case we can solve the problem as well. But he said, how can you say that? I said, I have a secret weapon. You know what my secret weapon is? The good old plan, do, check, act, the Deming cycle, or as Deming called it, plan, do, study, act. Anybody still knows what that means? I mean, I'm getting old. Younger people following, maybe they forget what that is. So let's rehearse. It's the plan, do, check, act. Now the problem is that most people don't do plan, do, check, act. They do pull, do, pull, do, pull, do. I call that the intuitive cycle. I can't call it plan. Yeah. What is the next thing I have to do? And I'm already doing. Next thing, I'm already doing it. Next thing, already doing it. So I can't call that plan, so I call it pull. So intuitive cycle, how we automatically work on the work in front of us, pull, do, pull, do, pull, do. Now, if intuition would be perfect, everything we do would be perfect, right? Not everything we do is perfect. So apparently intuition sometimes points us in the wrong direction. So instead of pull, let's plan. And plan is twofold, what to achieve and how to achieve it. Then we carry out the plan, and that's already a pitfall because the plan must be doable and we must follow the plan. But let's assume we did that. Then in the check phase, after doing, we can say, is the result according to the plan and the way we achieved it according to the plan? The result and the way we achieved it. And based on the learning, we can think, what are we going to do differently the next time? Because if we don't do anything differently, the result will be the same. Otherwise, statistics wouldn't exist, right? So most people, usually for the act, we don't have time, check and act. But in your mind, yeah, you know that actually we should do some things slightly differently to do it better, but we don't have time. Yeah, that's why I say, let's go to the act phase. Let's clearly think, what are we going to do differently every time we go through this cycle? And doing that, we call this the evolutionary cycle. We can change by putting mutations in the way we work to move to even better results all the time. Better results, better time, quality, on time. So instead of complaining about a problem, yeah, if you have heard people complaining about a problem, right? Stuck in the check phase, how about doing something about it? So one of my important mantras is, what are we going to do about it? If it's not a real problem, forget about it. If it's a real problem, what are we going to do about it? And the interesting thing is, we work with clever people. The moment you ask this question, these people usually immediately can come up with some suggestions what we could do to do about the problem. So I went there, I was allowed to come, and I went there and I said, where's the projector? Because there was a projector hanging there, but it didn't work. So after a few minutes, they had another projector and they put in the Excel file. And I said, first, let's find what the problem is before we jump to solutions. So there's the projector. And we started Excel. And I asked the guy, can you now put on what kind of things are in this pile? And I can't write what. This is the real Excel file that happened that day. The only thing I changed was the name of the activities, because of course I can't show the actual things from that company. But I just changed it in package 1, 2, 3, etc. So he typed in, he knew, he prepared already because I had been coaching them before. So this was the senior tester. And I said, now put the estimates. How much time do you think you need to get this package at the level that we can send it to the customers? Well, he put these numbers there. And then I said, now can you, these large things are not so easy to handle. Let's take one of the packages and cut them in pieces. So that's what he did. And after putting some pieces there, I said, now leave that 18 there. I mean, for the moment, it's the exercise, so we have enough material here. Now, adding up all the days was 106 days, which is about half a year. Now, the problem was we had a lot of angry customers already going to the competition. They didn't like us because we didn't deliver. The pile was there and nothing came out of the company. So the life of the company was on the line. And letting customers wait another half year was utterly unacceptable. So I said, how about the developers stop developing, because otherwise the pile only grows. The developers stop developing, and you as a tester, you have the whole development department to help you. You tell them what to do and they will do it. If you need the boss to do something for you, I make sure he does it. Can you imagine that smile already moved a little bit up? So I said, if you have the whole company at your disposal, what do you're still being the bottleneck. Yeah? How much time do you still need to get these packages ready to deliver to happy customers? So he looked at it and he filled it in, and after some time, this was the result. 47 days, which is about 9 weeks. Yeah. So just to make sure that the other part of the company was not overloaded, there was one junior tester. She could do a few things. And he said, well, developers, yeah, how many days would I need? So sanity check, 36 days, still less than the 47. So at least now the work was divided over more people. And then I said, okay, that's the work. Now, who is waiting for all this stuff? So he filled in the next column. And there were already some interesting things. If there's a question mark at the customer, if we don't even know which customer is waiting for something, why work on it? Yeah, like this one and this one. So I put on the whiteboard what I call a timeline. I like these lines on the whiteboard, tuck, 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 week numbers. You have heard in Scrum, they use usually 2-week sprints. I call that delivery cycles. But I found that people have some trouble with focusing on just one delivery cycle. It's good to have several delivery cycles so that you can optimize the order of doing things. So, what's the priority order of customers to be served? Because some customers are more important than others. Some customers are only screaming but never buy anything. Yeah. So, in which order are we going to deliver what to which customers? And we don't have to deliver everything to customer A, because what we deliver can keep them busy for some time, and in the meantime we can make other customers happy. Okay, so I said, now, if you look at this, apparently I was sitting there in 22nd of February. I said, can you make any of these customers happy tomorrow? for instance. So he looked at it and he said, well, yeah, I think this is a very important customer, and in one day I can make them happy. So you already know by now that I can talk a lot. So let's not think that tomorrow he can deliver because I'm wasting his time today. But let's say on the 21st, we can send this to the customer. So going further, the exercise, he said 28th February, I can make another customer happy, and the same customer in the 24th of March, they can have this, etc. So this was a good start. I said, okay, now you get the drill, you can do the rest yourself. So what was the result after this exercise and after some time? Tester empowered. Remember, I said, tester, you are in charge, you have the whole company at your disposal. Smile going up. People talk about empowerment. This is what we did. The whole pile was gone in 9 weeks. And the so-called full regression testing that was the boss had said, you shall do full regression testing. This is a rule to obey. When we were talking about this, there was a senior developer who said, Niels, you know, the so-called full regression testing, yeah, we have to do all the tests that ever were done on this module. However, in practice, that means only 30% of the software is actually checked. So what's the point? So I said, scrap the rule. We are going to deliver to eagerly waiting customers and make them happy. And the customers, because we were starting delivery every day almost, yeah, customers systematically got happy and amazed. So they said, what's happening with this company? First, they didn't deliver anything, and what they delivered was crap, and suddenly they're going to make us happy. This tester, he bought a small whiteboard about this size, yeah, and from that time he used that whiteboard in front of on his desk. He took it to meeting rooms when he discussed about things, and every week he filled it in again in the order of most important things, what to do in this week and what probably to do in the following weeks. Because sometimes it is good to tell a customer, in 2 weeks we will deliver this piece and it will work. Are you ready? Because if the customer says, well, that was a problem of 3 years ago, and that was an old project, that project is done, so we don't need this anymore, then we can work to another customer. Yeah. So from that moment, he kept up with development and never got the pile growing anymore. And when I came back half a year later, then they said, Niels, you know what happened? The revenue of the company went up 70%, and that's because of you. I said, because of me? No. I just spent 1 day with you, gave you some hints, and you were the guys who did this, right? So another year later, tester promoted to product manager and still coaching his successors how to plan. So, sounds good, doesn't it? So let's go through a few things techniques I was using here. I already called it the timeline process. How do we know that we get and do what is needed when it's needed? Quality on time. Now, standard projects usually think, what is all the things we have to do with the resources we have? And we put a little bit extra and then all is done. The problem, however, is that usually the fatal date is earlier. So, and then we have agile projects or agile work. So agile is doing our best to deliver working software, right? And deadlines are fake. Who cares about deadlines? So this approach, and we call it the evolutionary, because using this plan, do, check, act all the time. Yeah. Then we say, if this is the deadline, then this surely will be done. This surely will not be done. And this may be done because estimation is not exact science. Besides that, during the work, we probably will find that we have to change ideas, better understand what actually has to be done. So what will be done is not exactly what we thought in the beginning, but this is the principle. As long as the most important things are done and the bells and whistles that nobody actually cares about, who cares? And if we see that what surely will be done is not enough to ever get a good result, we can say, let's do something better, something else. It is better to have 80%, 100% done than 100%, 80% done, as long as it's the most important 80%. As I said, usually the customer says, bells and whistles, who cares? So I could talk about the fallacy of we have to do all the requirements. Now, some people, especially in the agile world, don't like that word requirements because it sounds so waterfally. So another word for requirements is what we think we have to achieve. It's exactly the same, but sounds nicer, does it? So often I hear we are done when all the requirements are implemented. Yeah, some people have this backlog and we have to do everything in the backlog. Yeah. Then I say, well, isn't delivery time also a requirement? In many areas, I hear that delivery time is one of the most important requirements. Yeah, like if it's not in the shop at Christmas, we don't need it anymore. Years ago, I was working on a chip for telephone, for in smartphones, and if that chip is not available at this GSM fair, I think it's in Barcelona nowadays, where the Samsungs and the Nokia, well, not anymore Nokias, but the phone companies are coming to see the new products. If it's not there, next year the chip is obsolete. Yeah. So deadline, I'm talking about real deadlines. The thing is, requirements are always contradictory, like some performance and budget, performance and time, things like that. So what's the optimum compromise between the conflicting requirements? That's what design is about. Not just starting the work, but see what's the optimum compromise. And do we really have focus on the real requirements? Now, what are real requirements? The real things we have to accomplish is not the features. The features or the functionality is just scoping the work we do. Because all the features we deliver to customers, the customers are already using. They banks for thousands of years. First with clay tablets, then with cardboard cards, and now with computers. Do they anything differently? They still do the same. They play with our money, right? So what's the real requirement if we deliver something to our customer, to our users? That is that they can do something better than before, nicer, faster, more productively. That's the value that we have to focus on. That's where testers should focus on. Are we giving them something that makes them more efficient than before, better than before, faster than before? Because if not, why would they use our product? And customers, they don't define the real requirements because we are bad at defining real requirements, but customers are even less trained in defining them. So what the customer says, I call that nice input to be taken seriously, but then we are going to think, what does they mean? And then we come back to the customer. I think this is what you mean. Is that correct? Well, exactly as we said, but not what we need. Okay, now we are talking. And then what we think we have to do should fit the available time, but because if it doesn't fit, we won't get the thing out on time. So instead of letting it happen, we decide how it will happen. Which requirements are the most important? Which functionality or improvement in functionality is the most important? And that we do first. So we saw this Excel sheet and we saw this timeline. What's the principle? We cut the work into chunks, we estimate, and some people don't like estimation, but after 1 or 2 weeks, a little bit coaching, it takes very little time. Adding it up, and usually most projects are late, right? Everything takes longer than you hoped, right? So usually it doesn't fit the available time once you see it on the timeline. Now, you already know what my mantra is there. If it doesn't fit, what are we going to do about it? Because failure is not an option. So we find strategies to solve the dilemma. The moment we ask your guys, if you work in that project, what are we going to do about it? You come with ideas, and that's a good start. We select what we think is the best strategy, predict what will happen when, and then we learn and we repeat every week, keeping the predictions up to date. Remember the whiteboard of this tester? Yeah, every week he redesigned how to optimize the best result in the shortest time. So another example of a one-person project was this, as an example. So again, I had to anonymize the activities, but this was a list. I said, let's look at your project. You're already working on it. When will you have done what? I hope. And that's the whole problem. What are we doing here? We are just objectifying. Instead of saying it will take so much time, I don't know how long it takes. Let's see. No numbers is worse than some numbers, even if the numbers are wrong. Because if the numbers are there, somebody can say, I don't believe that number. Now we are discussing. Yeah. So this were his estimates about his activities. And actually, when I started working with him, he already did some work of this project. He spent already so many days on these things. And on some of the activities, there was still something to spend. Now, the first interesting thing is to see the ratio of spend and what he thought, what he first thought and what actually happened. Because we can learn from that. If the ratios are about 1, we don't waste time on it. But if we see strange ratios here, it took 3 times as much, then we think, what did you think first? What do you now know? And what can we learn from that? We can also see what kind of activity was it. The same company was outsourcing some testing in China, and they used this same technique. And the Chinese always were ratio real estimate 0.99, 0.98, 0.97. Yeah, they were very good at estimation of the work. But suddenly we saw 4s and 6 arriving there. And then we thought, what kind of activities were that? It was not testing, it was some design of something new. So apparently the people sitting in that company were good in testing, but not so good in design. So then we can think, should they hire some designers? Should we teach them design? Should we keep the design, the nice work ourselves? So we can talk about it. The numbers, and the numbers don't have to be exact, as long as they indicate where we can improve. That's the first interesting thing of this. But the next thing is, okay, how much time did we spend and how much time did we estimate, and what's the ratio? So in this case, we spent, or this guy spent 40% more time than he originally thought. That's not bad, because apparently in his estimates, he forgot certain elements. Maybe he was only thinking about developing and not about testing, or whatever. I don't have to know the details, but even without the details, we already can see something here. So we said, okay, now let's assume, until we know better, that we have to add 40% to the remaining work. Yeah, here. I didn't calibrate these things because after working 5 days and he think I needed more one day, well, let's accept that. Yeah, I mean, so based on this calibration, we can say, well, how much time would he still need to get these activities done? And now comes the interesting thing, because the boss or the customer, they want to know, when is it done? Have you heard that sentence? When is it done? Now, before, he only can say, well, I don't know, or I hope at some date. But now, it was very easy. Where is, yeah. If there was some deadline at the 5th of June because they wanted to present it to some customers, yeah, the 5th of June, okay, then he could say activities 1 to 16 will probably be done and the others probably won't be done. Yeah, but 17 and 18 are more important. Okay, then swap them, put them in front of it, and then some other things will fall off. At least now we are discussing. So don't waste management time or boss's time or customer's time with story points or estimates or whatever other things. That's your realm. They only want to know, when do I get what? And based on this, you can give a better prediction than without this. And did it take much time? Well, this was less than an hour. So what do we do if we see we don't make it on time? Yeah? If you add up everything you think you still have to do, I keep saying we think we still have to do, because during the work we will change our idea about that. But to the best of our knowledge, everything we have to do easily fits. Okay, we might start and maybe we are done in time. If it just fits, well, better assume it doesn't. So we still have work to do. And sometimes what we need, what we think we need, takes more time than we have. Then there's even more that we have to think about it. So we talk about what until now we have done, good or bad, we can change. All we can do is, can we optimize the value still to earn? They call that earned value. So what's the value still to earn versus the time still available? Because if it doesn't fit, it doesn't fit. We count backwards, because the first time I made this picture, I put this last line beyond the fatal date. And then I thought, if the match is over, we can't score a goal. So I moved it in front so that we clearly see we started too late. Now, what are we going to do about it? Because failure is not an option. There it is. So what are the options we have if we see we are not going to make it? Now, the first 4 options I'm going to show you, I see them happening in almost every team, every project. I call them the deceptive options because they don't work. They make it even worse. But they're so strong intuitively that it's good to recognize them so that we can see this doesn't work. Let's do something better. So the first 2 is hoping. Yeah, we see it doesn't fit, but we hope maybe if everything goes right, as if everything always goes right. Come on, yeah. So if it doesn't fit, it doesn't fit. Or we have to succeed. So let's go for it. Yeah, well, if it doesn't fit, it doesn't fit. And is there anything of you? Well, I don't. In a live audience, I can ask and ask people to say yes or no. In this case, I can't. But anybody working overtime? Never ever work overtime, because you are fooling yourself and your boss. If you work 40 hours, it's already heavy, and you make a certain number of errors. People make mistakes. We are people, so if we do something, we make mistakes, right? Even testers make mistakes, if they are also people. So 40 hours is already heavy enough. You make a certain number of mistakes. If you get more tired because you work more than these 40 hours in a week, then you make more errors, which means in the end you're only working overtime to correct the errors you made because you were working overtime. So never ever work overtime, so that once or twice a year you have the energy to do it when it's really useful. Sounds strange, Niels saying never do it, but sometimes do it. Well, paradoxes are normal in projects. Yeah. Besides, never believe anything I say. Think for yourself. Maybe what I say is useful, but you have to try it out yourself. The fourth deceptive option is moving the deadline. Now, you may have heard about Parkinson's law. Work expands to fill the time for its completion. We spend the time that's available. Now, if we move the deadline the wrong way, there's more time available and we will use it. It's just human behavior. So the only way you may move the deadline is towards you, because then this law helps you to be more efficient. The student syndrome is similar, starting as late as possible when the pressure of the fatal date is really felt. That's a dangerous one. If you do a student exam, when do you start really studying? 3 weeks before or one night before? Be honest. So, number 5 option is a dangerous one, but sometimes necessary. Because can you design an airplane with only few people? Yeah. So let's assume a project of 12 person months. You can say we are agile, we're not working on 1 year work, but well, you can scale this to any size, even to a week. But let's assume it is 12 person months. We can do it with 6 people in 2 months, with 4 people in 3 months, with 2 people in 6 months, right? Wrong. That's the myth, that's the fairy tale of the 1 month. That's how project managers calculate projects, but it doesn't work. It has nothing to do with reality, which Brooks in 1975 already called Brooks' Law, adding people to a late project makes it later. So can we open a can of developers? Can we open a can of testers? It makes it worse. Now, Mr. Putnam actually measured it. He took 500 projects that had been run already, so they couldn't tamper with the numbers anymore. And he found it was projects of similar size, but different team size. He found that the cheapest project is 2 people. The fastest project is 5 to 7 people. But it's only 20% faster. So, is that good? Well, time to market is an economic value, so this is probably somewhere the economic optimum. And some people think you take 9 mothers to make a baby in 1 month. Well, we know that's not so easy. So we call that the 9 mothers area. Some things take the time, a certain minimum time. And beyond 5 to 7 people, 8, 9 people and beyond, the work explodes because there are more people to pay and it takes longer. So how do we design an airplane? Well, probably you don't survive as a company. And if you do, it takes longer and longer and longer. So we can't go around this law because it's just the human behavior stuff, but we have to learn to work with it, to see what we still can do. Now, the sixth option in saving time, that's the low-hanging fruit. And the interesting thing is, and that's what I'm always using when I'm coaching teams to deliver better results in less time, that is so easy because half of what people do in their work later proves not to have been necessary. If in a retrospective we see we did something that was not necessary, the time is already wasted. If in a perspective we see that we're going to waste time, we can still decide not to waste it. It's that simple to save time. But we have to do it. We have to think, what are we going to do? Is that the right thing? Will it later be proved to be not necessary? Then we still can decide not to do it. And that's in many levels. The efficiency in what to do, why to do it, for whom we do it, doing the right things, not doing what later proves not to be necessary. Efficiency in how we do it, the product, how to solve it, the project, how to organize it, and continuous improvement. Efficiency in when to do it in the right order. Remember, on my timeline, I used several delivery cycles to optimize the order of delivering things. And time boxing. Yeah. Feature boxing is the opposite. Feature boxing is waiting until it's done. If there is no deadline at all, Parkinson's law, we will spend the time. Time boxing helps you to be more efficient. That doesn't mean that the quality is bad. That's why I always keep talking about quality on time. And we can call this continuous elimination of waste. Ever heard of that? Ever heard of so-called lean? Plan, do, check, act. Continuous improvement, continuous elimination of waste. That's the secret. And then the seventh one, I think I didn't show that here, is killing the project instead of doing it after 3 times the budget, what we often see. So even more important than deadlines are starting deadlines. If you focus on the fatal date, you will go over it. Don't worry. So if we focus on the starting deadlines, and what is a starting deadline? It's the minimum time to finish the job, that counting back from the fatal date to the starting deadline. If we start 1 day later, we already now know that we will finish 1 day later. Yeah. Most projects or most teams find out 1 week before the fatal date, oh, we didn't make it, we did our best, we macho and etc. Sorry. But if 1 week before the fatal date, there's not much you can improve. But the interesting thing is you could know much earlier. And then if you say it's utterly impossible to deliver at the fatal date, you can discuss with your stakeholders, with your customers, with users, what are we going not to do? Or are we killing the project and spend our time on better things? Hopefully, the things we have to do are starting after now. And then this area of between now is that we can move all the starting deadlines this way, all the starts of these things, because you can't do everything at once. So you have to do things in the right order. So more important than end deadlines are starting deadlines. Focus on them. This is a picture of what we actually did on a whiteboard. Here was some deadline and there were streams coming here together. This was the electronics PCB with some firmware on it. It was for a parking system, payment machine, the case where you pay, the credit card put in, a coin changer. All these things had to come together at the same moment. And then the project manager of this, he said, I have to put this nicely on the PowerPoint slides. I said, why do you have to do that? We are in control here. We know exactly what to do. Yeah, but I have to show it at the top floor to management. I said, well, we can invite management here. Huh? Yeah, you call them. And I put some chairs in front of this whiteboard. And the guys came and they sat there and he explained this picture that we made together. And the manager said, oh, looks good. Seems you're good in control. Continue the good work. And they left and they were happy. So this is, I showed some element, timeline, of what I call the Evolutionary Project Management elements, short EVO. Tom Gillip, some people may have heard about the guy, yeah, came with all this stuff, well, most of it. Plan, do, check, act, the secret tool. Business case, why are we going to improve what? Requirements engineering, what are we going to improve and what not? That's at least as important. And how much will we improve? Quantification. If you don't quantify, you have no clue where you're going. Architecture and design, selecting the optimum compromise for the conflicting requirements. And early review and inspection, measuring quality while learning to prevent doing the wrong things. So this is all things I'm not going to talk about today. We have only 1 hour. So, and I showed you the timeline, but what I added to what I learned from Tom Gilp is the project planning, where actually I do the same. We quantify not only the product, we also quantify how to get there. A weekly task cycle, a bi-weekly or less delivery cycle, and timeline. So this is my toolbox with zero defects as an attitude. We can talk about that, but no time today. Business case is why. Requirements is what, how much are we done? Architecture and design, how are we going to do it? Early review and inspection to check and learn as early as possible. The weekly task cycle is to improve the efficiency of what we do. The bi-weekly delivery cycle is the effectiveness of what we do. And timeline is what will happen. And most important, what are we going to do about it? Because usually if you put on the timeline what you think will happen, of course, to the best of our current knowledge, and it will change during the time, I know, but every time, to the best of our knowledge, what will happen, and we will see that it doesn't fit in the available time, what are we going to do about it? So it's about the right result at the right time, and I call that quality on time. And I showed you now the timeline, and because we still have 10 minutes left, I want to talk about the weekly task cycle. In the weekly task cycle, you also can use your timeline, but that's your personal thing. In the weekly task cycle, we think, are we doing the right things in the right order to the right level of detail for now? If we do too much detail and after 1 or 2 or 3 weeks, we find out it wasn't the right thing, we have done too much. So what's the right level of detail for now so that we, as quickly as possible, see are we in the right way or not? And if not, we have to redo as little as possible. We optimize estimation, planning, and tracking abilities to better predict your future. Select highest priority task. Never ever do lower priority task. And if we get an undefined task, we first check, is it more important? Then we do it. If it's not, we don't do it. There are about 26 plannable hours in a week. Only 26? Are we going on holiday? No, this is 2/3 of the available time. 40 hours times 2/3 is 26, 27. So the 1/3 is for all the small interrupts that we have. Have you ever worked the whole week and at the end of the week the pile was actually still there? So what we do is all the interrupts we get like going to the toilet, drinking coffee, helping each other, small interrupts, people asking questions, helping each other, all these little things, they happen. We don't have to plan them because they happen anyway. But we limit the time to 1/3 of available time, so that 2/3 of the available time is there to get the actual work done. So the other 1/3 is also a support for the work, but not direct, necessarily plannable. Yeah? Tasks are always done, and the person who is doing the task defines what 100% done is. Delivery cycle, are we delivering the right things in the right order to the right level of detail for now? Yeah? Optimizing requirements and checking assumptions. We better assume that our assumptions can be wrong, but without assumptions we can't start working. So we have assumptions, but in feedback cycles we have to find as quickly as possible which assumptions are going in the right direction and which are not. So what will generate the optimum feedback? We need feedback to make sure that we are on the right path. We deliver to eagerly waiting stakeholders. If stakeholders are not eagerly waiting, why deliver to them? Because we need the feedback. But if we need feedback from these stakeholders who seem not to be eagerly waiting, we have to make them eagerly waiting to deliver by delivering juicy things that make them eagerly waiting. Yeah, many stakeholders have been in these Scrum demos where they see all this boring stuff. Yeah, where they say that button is blue, why is it not yellow? And then somebody writes down it must be yellow and things like that. Yeah. So main thing is what will make the users or other stakeholders more productive now. And delivery cycle never more than 2 weeks. Probably less. How do they come together? We see on the timeline we have delivery cycles, and delivery cycles are fed by work to do, tasks cycles. In this week we work on these things. Some deliveries may take a little bit more than a week, so we may work on those. And this is maybe not so good because if we do these things later, let's go to this. Out of the delivery, we get feedback, which may affect the definition of this task, may affect the definition of this task. Now, assume we have done this task too early. We have to do more over. So this is the general picture. How do we do this weekly planning? We try to do this with as little time as possible, as efficiently as possible. So instead of sitting with the whole team thinking about everything, individuals knowing what we are going towards, knowing, and as a team we have defined what we should accomplish by the end of the week. Now individuals can prepare what they are going to do to feed the successful accomplishment. And they can first think themselves, not waste other people's time. Then they come in a one-on-one. Why spend with many people if 2 people can first discuss and help each other to ask questions? Is that really necessary? Who's waiting for that? Well, if nobody's waiting for that, why should we do it? Yeah. So there we think, what happened in the previous week? What can we learn from that? What is the most important thing to do the coming week? What fits in the available time? And this is my plan to help the team achieve the team goal. And then we have a team meeting where people go through, I'm going to do this, this, this. I'm going to do this, this, this. Next guy, this, very short. And then somebody says, yeah, but you can't do that because you need me and it's not in my plan, therefore I don't have time for you. So we modulate in the plans instead of generate. Generation costs more time than modulation. Generation costs here more than modulation on the team level. So In the group meeting, we have formal confirmation, concurrency, how it does fit together, learning, helping, socializing. How much time does this take? Some people say this is quite some planning session. Well, the first time it may take a little bit more time, but after a few weeks, this takes 20 minutes, this takes 20 minutes, this is 20 minutes. 1 hour per person. Is your planning, your weekly planning ever so short? So, how do you do it? You think, how much time do you have available for the coming week? Let's say it's 40 hours. You take 2/3, let's say 27, 26, it's your planning, your success, your contribution to the team. What's the most important thing to do? Estimate the effort to do these things. Which most important things fit in the net available time? Which doesn't fit? What can and are we going to do? What are we not going to do? In this case, we know already 1 week earlier that this won't be done. Yeah, but it also must be done. Well, we already know it won't be done. And if it's more important than anything above the red line, we can swap. And 2/3 we found is a good starting value. People can change this based on their experience. An example, I was sitting somewhere in the UK with a team. And John came in and 26 hours available, and this was his plan. Okay. The first time I just accept anything. 1 week later, this was what actually happened. So some things were done, some things were not. Why were they not done? Because some things took much longer. Now the things, we already did that with the tester earlier. If it takes about the same, we don't waste time on it. If there is a significant difference, and it's up to the person to define what significant is. 5 he thought, 13 it was. What did you think first? What do you know now? What's the difference? And can you learn from that? That's the analysis. And then we learn from that to, in perspective, plan our next week. So this was his list of things he thought he had to do in the coming week. But we already know it would be a failure, and failure is not an option. What are we going to do about it? Yeah, but I'm working for 2 teams and I have to deliver all this stuff, otherwise they can't continue their work. I said, well, let's invite the project team leads of these projects, or the whole team, I don't know. That's up to you. So he said, this is for project X and this is for project Y. I said, do they all need this? Do they all need this in the next week? So we asked from the team people, and they said, well, this I need next week, and the others can wait. This we need next week, and the others we don't need yet. Okay, now he had 26. Now there was a chance that he would be successful. Simple. Don't tell what you're going to do if you already know you can't succeed. So we talked about the timeline and weekly task cycle, and I can talk about a lot more things, of course, but we don't have more time. So why is this so important, this weekly planning? Task cycle planning is not just about planning the work for the coming week. It exposes issues immediately before they actually become issues. Half of what people do in project later proves not to have been necessary, so better in pre-spec we see what we shouldn't do so that we still can decide not to do it. If people come into this planning session, the one-on-ones with me, they come in with one plan and they go out with a different plan. More working on the right things and less going to work on the not so important things. Immediate saving of time. So doing the task cycle planning, we can see what our colleagues think they're going to do. People say after this team meeting, they say, for the first time, I know exactly what everybody's going to do and why they're going to do it and how and when we have during the week have to work together. Make sure we're going to work on the most important things, not on unnecessary things, in line with architecture and design, most efficiently to the goal of the delivery, and everybody knows exactly what's going to happen, what not, and why. So, would you like the same? To be empowered, to be done in the shortest possible time, etc. Focus on the result, then think how to achieve that result successfully and efficiently. Delivering quality on time. Problem solved. Thank you.
Thank you, Niels, very much. So we could move to our questions. We have quite some. So let's start with the one I like most. So, how can you achieve zero defects, and how do you foster a zero defects attitude, especially in a legacy application with a demotivated team?
Let's make another meetup about zero defects. But you also can go to my website at conferences and find zero defects and see a video about it. Yeah, it is. Well, let me tell you a short thing, a little thing. Most people don't believe it's possible. I mean, I've done it many times in product development, so I know it's possible. I even can prove you immediately because by accident there could be no errors, right? So it's possible. Yeah. The thing is, how do we make it possible in our work? Now, it's not turning a knob that suddenly we don't make errors anymore. People make mistakes. We are people, so if we've done something, we make mistakes. There are mistakes, right? And then testers come and say, "Ah, we found your mistakes." But testers are also people, so they also make mistakes, right? So the whole thing is we have the learning curve. Yeah, and the learning curve makes us doing better and better, making less and less and less mistakes. Now, if the target of this learning curve is at 13 errors per 1,000 lines of code, yeah, or 20 bugs missed, yeah, for testers, yeah, if that's your target, guess where this learning curve goes to? The only way ever to go near zero defects is to have it as your target. From now on, we are not going to accept ourselves to deliver defects anymore. And we're going to learn to do it. Yeah. So if we do the tester thing, I go to many testing conferences and I ask the people, yeah, testers, do you find bugs? Yes. Do you find similar bugs again? Yes. The first time it was the so-called fault of the developer. The second time it was your fault. Because why didn't you help the developers when you found it first to learn never to inject similar defects again? Yeah, but then we lose our job. I said, don't worry, that will take a long time. Yeah. Besides, now testing becomes more interesting. Now we're moving to QA. Because if there are bugs and you find them, that's easy. But how do you prove they are not there if they are not there? So I can talk hours about this. I know it's possible. If you don't believe it, we can talk about it. You can send me emails and you can discuss. Yeah, I talk with people on Zoom, and you can listen to my videos, whatever. So if you don't believe it, I didn't believe it the first time I tried it. I didn't believe it. There was this team where a product didn't really work. I said, well, if it doesn't work, we can't give it to customers. What's the point? Yeah. So from now on, I don't want to see defects anymore. It took them 2 weeks to find out I was dead serious about this, that this wasn't a joke. And then after another week, the testers that were sitting in the corner, yeah, they came to me and they said, Niels, something weird is going on. We don't find bugs anymore. I said, isn't that what we want? Is that enough for the moment?
Yeah, this was definitely a good overview, and here I'd also like to add something, especially the part of the question about how. So it is great that people can go and watch your material, and maybe you can provide links later. but also just to add on maybe a short answer, I would start off with continuous integration first. So that's the minimum. So the minimum is setting up, do we have a pipeline? So there's still teams who still don't have a pipeline. So the minimum is the pipeline, and that the pipeline should automate at least, build and test first.
Yeah.
And then also deployment.
Yeah, sure. But usually when I work with a team, I don't want to tell them what to do. They're clever enough, just like you know some suggestions. Whether that's really the first and the most important thing to do first, could be. Yeah. But plan, do, check, act. We can try it, and then we see, did it actually work? Yeah. And are there other things? So I don't have to tell people what to do, because people are clever enough and they know these things, but because of the treadmill, they don't have time to try it out. Yeah. So the moment I say, and that's what happened in that project, I said, I don't want to see the defects anymore. Simple. Yeah. And zero defects is so cheap, because I said I don't want to see them anymore. And after a few weeks, when they found out I was that serious about it, they didn't make them anymore. That's simple. That's cheap. Didn't cost anything. Only a change of attitude. There we are. Attitude. So if you can't do it, you can hire me.
Okay, great. Thank you very much, Niels. Let's move on to the next question. Now we received quite some of them. Let's proceed to this one. Do you think all bugs should be addressed? What is your opinion on bug trackers?
What bugs? Bugs shouldn't be there. I mean, again, in my zero defects talk, you will see that I ask the people, the developers do their best to work towards what is necessary. Some people call that requirements. Yeah. So we have to accomplish things, and we do our best to do that. I'll put some light here. Yeah. So they work hard to do that. So if they produce bugs, I must assume that a certain number of bugs is required in the requirements. Otherwise, why do they make them? Yeah. So I asked the testers, can you check that the required number of bugs is produced? And if I say that to the audience, you see them thinking, yeah. There was this bug tracker. I was at a company where they had Bugzilla. And they had, I think, 4,000 bugs in Bugzilla. Some were 15 years old. Yeah, who was waiting for that bug? Yeah. So I said, let's first, actually it was the same tester, but a little bit later. I said, let's get rid of all these bugs until we get them down to 14. He said, why 14? I said, well, if you have 14 bugs, you need the tracker anymore, because then we can think how we can get rid of the remaining 14. Yeah. So they had this Bugzilla, and I put in there, they had a box from error, the cause, and the solution. And I said, let's put two other boxes there, root cause and root solution. So a year later, I came back and I looked at these boxes, and in the root cause, I saw the causes, and the root solution, I saw some solutions. I said, guys, I have to explain something. There's a difference between the cause of a defect and the root cause of a defect. The cause of a defect is what error caused the software to malfunction. The root cause is what caused us to inject this defect, to cause this malfunction. And that's what we are after. If we find what caused us to do it, we can try to prevent it. And that's the name of the game. The most important task for testing is not finding and repairing bugs. That's a byproduct. The main product of testing is feedback towards development to feed the prevention process. So I hope that's some answer to my opinion about bug trackers. They shouldn't be necessary.
So I guess so. Let's look at this one. The next one is about the process of working. So can QA also work in pairs, mob, or are they expected to work alone?
There's one general answer here. Plan to check act. I don't have to tell you. You're clever enough. People in the team ask me, Niels, you said we should do this, but maybe we should do something differently. I said, well, you can try it. But after you try it, then check, was it better? If yes, maybe you keep doing it, or can you do it even better? If not, yeah. So there was this guy. I said these one-on-ones that we do with people in the team, I do not behind their desk, not behind my desk. But if I'm coaching, I don't have a desk. But we do it at a different place. We take people out of their normal work to focus really on what we are doing there instead of being distracted by everything on their desk. And then this project manager, he said, or the team lead or whoever we call him, he said, Niels, you weren't there last week. And I thought, let's try, I just stand next to his desk and let's talk about his next planning of the week. He said, now I know why you told me not to do it there. Thank you. Yeah, so don't believe anything I say. Try it out, but plan to check whether it worked better. Maybe then you could doing it. Maybe there's even something else better. Yeah. Learn. That's my general answer. That's how I come to this answer, by asking questions. I call them innocent questions to make people think. So in pairs or mobs, you try it out, but don't do it because other people say you have to do this. On LinkedIn, I see all these people, you have to do this, you have to do that. Years ago, when I just started my career, I was, as a coach, I was sitting on some dinner table. I don't know where that was. And I was sitting next to a lady. And after some time, she said, Niels, all the time I hear you say that I should do this, I should do that, I should do that. Stop doing that. That was a very good learning point. You shouldn't do things because somebody says it. Find out yourself. You're clever enough. And because quality costs less, the moment something helps you to do something better, you will do better things in less time. So you have the budget to experiment.
Thank you very much. Let's talk a bit about TDD. Do you promote TDD in those teams to reduce the number of defects? What's your opinion on TDD?
Well, if I read descriptions of a TDD, I see strange examples. Like somebody said he had to, as an example, we have Roman numbers and Arabic numbers and how to change from one to the other. So first we define a test whether one turns into a Y, and we make some software until it works. And then we do a test to have two Ys, and we make some software and make sure that 2 translates into 2 Ys. So, yeah, come on, guys, don't waste my time. Yeah, I'm an engineer. Engineers learn how to design so that you know it will work if you do it. But actually, that's what I read in this TDD. Yeah? TDD is a trick to make software people do some design finally. Then it's okay. I don't mind how you call it, as long as you do the right thing.
Sounds great.
And you measure whether you reduce the number of defects. I don't have to tell you.
Valentin, do you want to add something?
I think that this was a really great topic. I mean, is TDD needed or is it not needed? Now, from the perspective of continuous, for example, integration, the only requirements that's stated there is that code has to be self-testing, so the existence of automated tests, but it does not specify whether or not it should be achieved by TDD or test last, because both of them would lead to self-testing code. So then I guess it raises the question, that does TDD matter at all? The difference which I've seen is the difference in the reliability of tests, more specifically the ability of tests to detect regression bugs as measured by mutation scores. What happens in most cases is teams which are practicing TDD properly will naturally get quite high scores on mutation score, whereas teams that are practicing test last development will generally get quite a lot lower mutation score, indicating lower reliability test suite, i.e. a test suite which is not catching regression bugs. So I use that as a motivation for teams whenever anyone is asking the question, should we use TDD, should we not? I'm like, run the mutation test. And even though your code coverage could be 90 or 100%, the mutation score for a test last team might be 10%, 20%. And then, they get a shock when they...
You know what people do? You know what people do? If you don't get those results, they tell you you don't do TDD properly. Now, test automation is also writing software, right? So shouldn't you, just like you have to design your software, because otherwise it takes longer, shouldn't you design your test? And shouldn't you design them at the same time? Because then you have cross-pollination about better understanding what the stuff should actually do. Correct. And how do we know that it does? And don't forget, 20% of the software is there to make the computer do what it should do. 80% of the software is there to make the computer not do what it should not do. Is that tested? Did you check that with inside your TDD thinking? Yeah?
Yeah,
I can go on for hours, but maybe there's another question.
Yeah, it's about expectations, and TDD simply forces developers to think about expectation rather than just launching into code without thinking about behavior at all.
This is logical. Yeah, typically better than done with TDD than test last, of course. I mean, yeah, test last. First, we asked all the developers, you're people made mistake. So first we wait until you have injected all the defects. Yeah, and then test last, we try to find all the defects which we cannot because we are also people. Yeah, so what's the point? So testing, especially final testing, should not find a single defect because testers don't find all the defects. And therefore, the moment they let's say the test efficiency is 50%, which means if the tester finds one defect, the customer will find one. If they find 5, the customer will find 5. How much should the customer find? 0. Therefore, at the final test, tester should find 0, and that's very difficult. As I said, how do you prove they're not there, even if they're not there? You have to use other techniques, and TDD is one of the many techniques you can use there. It's not it is one of them. Document inspection and design review are much more powerful, which actually good TDD people, I think, do. Every time I get stuck, I mean, I'm not better than others. Yeah, if I make some software, yeah, I get stuck in all the spaghetti I produce. Yeah, and then I say, Niels, go back to your design. And of course, the design is not anymore up to date. So I call that reconstruct the design. Now, I was in Hungary at the test conference, and there was a very old guy, great guy. I think he was 80 years old. He said, I was the first tester in the country. And the first software we got to test was from Siemens for a nuclear power plant. So they got a module of this software to test. And he said, we found in that module 350 bugs. He said, then I used the word, we reconstructed the design of the software. And we found 3,000 bugs. So just testing the code is waste. Most of the cost of the errors is in the requirements, 50%, 30% in the design. And who cares about the bugs in the code if you didn't first review that the requirements are what really is necessary, that the way it is turned into a design is the best way to do it. And then to see that the code actually does as you planned it to do and does not as you planned it shouldn't do. Do you hear these things many times at other people? Sometimes I think I'm coming from another planet. Some people may think so.
I think that these are all great points, especially the part about starting at requirements, and that's yet another reason why where I see certain benefits of TDD, because we're actually converting the human written requirements into essentially executable requirements.
Yeah.
And I found in practice that teams who are using TDD ask a lot more questions when it's challenging to convert a requirement.
So that's why I call it a trick to move people leftward.
Correct. And in that process of asking those questions, it makes the owner of the requirements, like let's say the product owner, think a lot more, and it generates a lot more conversations with users and other stakeholders, which consequently leads to better requirements. But plus the other also point I want to add here is when we have that self-testing code and when we release, by that feedback that we get from users, that's also the ultimate feedback. Are our requirements correct? Because actually no one can know whether the requirements are good or not until it's actually released into the hands of the users. They are the measure.
As long as that is not just trial and error. Because we can imagine, you don't have to make code to, I always say, let's observe what the users are doing. Yeah.
Yes.
And when we give them code, we observe again, what are they doing now? Yeah. One of the pictures I use is I hear Scrum teams doing a so-called demo. Yeah, they were on the parking system where they were doing this demo, and they showed a nice picture of the software to do payment for the parking. And then the R&D boss said, "Can I now fill in something?" Huh? This is agile. This is a demo. We tell you what we've done. I said, can't he try and see what happens? Okay. So can you fill in here your credit card number? They said. So he typed his name, crash. Yeah, you must put in your credit card number. I said, the user is always right, even if he's not. Yeah, don't demo stuff, give it to them, and see what happens. Yeah, but how do they know? Well, if they buy the software, they also don't know. That's up to you. You're clever guys. Make a product that is so intuitive that the users automatically know what they have to do. If not, what's the point? Etc., etc., etc. Part of the zero defect story.
I can imagine we could make a separate session about this topic. Let's move to the GPT topic, since it's very, very current at the moment. What is your take on automatic test generators like GPT?
I don't know, because I didn't try it out. If you tried it out, maybe you have some idea. And what I hear about GPT, what I tried myself with GPT, the few things, like I'm Dutch and my wife is Japanese. So I asked in Dutch, do you also know Japanese? And GPT said yes. So she could ask in Japanese, got great, perfect Japanese back. But whether that has to do with actually what, remember, it must check that the computer does what it should do and that it doesn't what it shouldn't do. Well, maybe GPT is better at that. Try it out. Plan to check act. Plan to check act is my magic tool. It always works.
Are you planning and check it out?
No, not at this stage.
So I guess Maximiliano
I'm
can
not a tester. I'm a poor electronics engineer, and I work on my own website. I make some tooling. I don't like software tools, but some simple tools for my coaching. But that's all I do.
Okay, great. Let's move to probably the last question of today. So, how should the team balance be? Is there an ideal rational or learning curve for the number of experienced and inexperienced personnel?
Well, the inexperienced must have a chance to learn, but not at all cost. So everybody has the right to learn doing the work, but not at all cost. That's a short answer. So you have to balance, as you say. But should I put a number there? Yeah, 3 and 5. I don't know. You find out. Yeah. The thing is, with experienced people, they must have a right attitude. Some experienced people just say, well, those juniors, they don't know, I can do it much faster. Yeah, if I do it myself, it's done quickly. But then the juniors never learn. So these experienced people must also have an urge to get these juniors to their own level. Yeah, but then they're younger and they're maybe more clever, then they get better than me. Well, why not? Then you can go on holiday. Yeah. So no, everybody has to learn, not at all cost. And what's the balance? Try it out. Too many juniors may take too long. And you can do some measurements, as I showed in the presentation. And in those measurements, see where their weak points are. I showed you the example where the ratio between actual and estimate was about right and not right at all. Yeah, so that can indicate elements that you can help them to learn. And actually, those experienced people, they also have learned. Did they forget that before they also had to learn?
Yeah, I also think it's very, very difficult to call a number. Maybe Valentina
Exactly.
has a feeling for a
Yeah,
number.
this is an interesting one because I have worked with both teams which were senior, but also even starting with teams which were nearly all junior, where maybe there was just one senior team lead. So I have seen opposite extremes of the spectrum. I would say that there are a few contextual factors which may affect companies choosing which way to go. So in cases where there is a really pending, short timeline and something which requires people to get up and running, then that kind of manager cannot afford risking or waiting for months that maybe someone will learn, someone will not. And in that kind of really crunch time, companies, the optimal could be even choosing a full senior team because something has to be delivered. Maybe the whole company future depends on it. However, on the other hand, from a long-term perspective, so when the manager is doing long-term planning, that is not sustainable. One of the reasons it's not sustainable is because, well, they won't be able to retain the seniors anyway for years and years and years. They get key person risk because suddenly those seniors become the holders of all key knowledge and they become actually a company risk. And that is why, for long-term purposes, the company needs to invest in hiring essentially new developers. And the benefits I find about juniors is they are like a blank slate. So this means if there's new practices, they will, I guess, be much more open to learning something new. And it gives a chance for the seniors to mentor someone and actually to build a learning culture. Because if you've got no one that you can teach or transfer your knowledge, then there is no learning culture. So just to summarize, I guess in my view, from a long-term perspective, I would say definitely there has to be a mix in building a company with both seniors and juniors. But just from short term, sometimes if there's crunch time, then the company might shift towards more seniors for a certain product.
There is another element there. The so-called experienced ones may have their way of doing things.
Yeah.
The juniors don't have that, so they may find solutions that may be even better than how we always did it. So the so-called experienced guys, may also or should also be open to let the others think with them, and their pair programming not all the time, but sometimes can be useful because you can learn from each other. Yeah. Document inspections are also a very good learning tool, especially in the way I've learned to do it and how I teach that. So that many document inspections are never done because they explode, because people have not learned how to do that properly. And then it's a waste of time, and therefore they say we shouldn't do it. But that's another story. So be careful. Experience doesn't mean they are better automatically.
This is such a great point. Thank you, Niels, very much for your answers and for your presentation. I enjoyed it a lot. I guess Valentina as well.
Yes, I thought that it was really great that you covered all of these points and the philosophy behind it. So I think that these are some great points to think about, especially the part how you mentioned, instead of giving out answers or telling someone what to do or this is the right and wrong way, that actually teams should develop a learning approach and learn as they go. So yeah, thanks a lot. We learned a lot today.
Thank you. I hope so. Then we didn't waste. I usually say, I hope I didn't waste too much of your time.
No, we learned a lot. Thanks a lot for today.
Okay, you're welcome. Happy
We
to
learned
be
a
here.
lot from you. And you guys keep learning how to deliver quality software faster and keep following us on different social media platforms. And don't forget about Discord and bring your discussions on Discord. Thank you very much.